So right now you're watching a feed, like a video feed that's being encoded into ASCII characters on the fly using some pretty simple Python program. It's not a, not an especially novel idea. I'm not the first person to do this by any stretch. But I was watching a video the other day where someone did this procedure, and I thought I knew something better than they did. I thought like there was a better way to go about doing it in terms of how our visual system works. But as it turns out, like either I was mistaken or it doesn't work as well as I thought it would. So I basically spent most of today implementing that, and since it wasn't really that impressive and didn't work especially well, I decided I'd also throw in terminal color, like, since why not? What else have I got going on? So let's see my first step of what I thought would be better. So right now, what you're looking at is I'm taking an RGB image, and I'm taking the pixel intensities in that image and converting them directly, like into like just scaling a range of intensity, like from 0 to 255, bucketing it in linearly into a bunch of different chunks. I think about 29, and then for each of those chunks, a certain ASCII character is assigned to that chunk based on the pixel intensity. What I thought would be better would be to switch to logarithmic scaling, because that's kind of, I think, closer to how our eyes work. Citation needed probably on that. But let's take a look at what that looks like. So this is linear scaling. Let's look at logarithmic scaling. It, I don't know, seems worse. But I did it anyway, so there is that. So logarithmic scaling. Let's now switch back to the linear scaling because it's a little chunkier. Well, I didn't actually just want to go back to linear scaling. I wanted to go to colors. So here we are in glorious 256 colors, 8-bit color from the terminal. And you can see me in glorious 8 bits, all those little ASCII characters. Here is a Rubik's Cube. It's kind of hard to see it basically at all, but this math textbook in yellow is, it's kind of yellow. It's pretty good. 10 out of 10. So maybe you care about how to go about doing the color encoding. So unlike the pixel intensity, which can just be read off directly and then either bucketed into linear or like logarithmic scales buckets, the color the color bucketing is a little bit more involved. So unfortunately, there's no like simple like collection of there's no simple way that like xterm 256 color scale is like put piece together. They're kind of all over the place in terms of their RGB values. But what I did was I took all of the 256 colors and then I formed a KD tree to be able to use the KD tree to very quickly identify the nearest neighbor in terms of pixel color. So I throw in an RGB value. I don't know what bucket I want to put it in, but I find the nearest neighbor using the KD tree of the 256 terminal colors, and then I just use the nearest neighbor color. So yeah, that's how this awesome thing works. So that's that. Here's some more of the same. And here's a live stream that shows that it is, in fact, actually working on the fly. Okay.